All right, everybody, welcome back. This is part 2 of the video, the detailed example of the Manual J video. So the detailed example video using the Manual J Speedsheet. All right, so in the previous video, we finished up all the windows and glass doors, as well as all wood and metal doors for the property. Just to pull it up again, so here is the floor plan. So we've got this front door. We're going to assume it's a nice big front door. And we've got the, let's call it a back door that comes out of the mudroom. We did these sliding glass doors here that we have in the great room that lead onto the terrace. And then we did all of the windows. So now what we need to do is we need to move on to the next section, which is going to be above grade walls. I had said in the first video we were going to, if you follow right here, we were going to use Phoenix, Arizona as the location for the home. Okay, so in Phoenix, Arizona, new construction walls are required to be R13. That means the level of insulation, right, has to be a minimum R13. So let's take a look at the walls here. Do they have? Let's see what they have preloaded. They have here a block wall. Okay, that's fine. Meaning that it uses like cinder blocks as the home construction. That's okay. And that it's got an R2 board, and I'll show you what that looks like. We'll use our trick with the RightSoft software, and then it's got R13 insulation in the cavity. All right. So the U value is 0.75. So here we go again. Now we're in our RightSoft software, and again, the reason why I'm doing this is because if you don't have the Manual J book, or I can't show it on screen, okay, so what I can do is I can use this tool, which is freely available for download. And I'll draw a room. Let's pull up the properties. Let's go to wall. All right, click on the 3 dots over there. Let's build a wall. Actually, I'm not going to go with the block wall. I'll go with the typical frame wall. In Arizona, it's very common. Actually, even though we had that picture of the home, it showed definitely not. It wasn't stucco. It was like some kind of siding, like a vinyl siding. Yep, something like that. Okay. Sheathing, we'll say that it's got a 3/8 wood, 3/8 of an inch thick wood sheathing. That's typical. We'll say R13. On the inside, you're going to have, at the very least, you're going to have a some kind of sheetrock or something. Okay. You might even have like an exterior board. It's very common, especially nowadays. Let's leave it as none, okay? So here we have R13 as our cavity insulation and our 1/2 inch sheetrock. So we see here this this MJ8ae U value of 0.91. So we will plug that in here into our wall. 0.91. Does it say anything about the group? It says group GC. Okay, all right, so we're going to call this typical frame wall, and this is R13 cavity. Okay. So we are going to use that for all of these sections here. All right, we'll go room by room. And we will populate the area, the wall area. Okay, so that the wall area is going to be your length times your height of the wall. Okay, and then we'll deduct from that the net area of the windows. All right, so let's get into it. Let's say here, let's start with the master bedroom. So we've got here. Wait just a minute. Okay, so we'll start with the master bedroom. Okay, so looking at the master bedroom, where are we again? Here we go. Okay, so we've got one long exterior wall. Again, we don't care about the interior walls. Exterior wall, and it says it's 12.4 by 16. So 16 is this length dimension right here, and we're going to assume that it's an 8-foot wall. Okay. Now you might say the exterior is a little bit taller than the inside. It's 8 feet on the inside. On the outside, it's probably a little bit more than that, but let's just leave it at 8. That's totally fine. So we will do this. We will do open parentheses. Now hold on a second. Let me zoom in here so it's a little easier for everyone to read. Okay. So we're going to start a formula. So we'll press equals, open parentheses. So 8 is the height times 16 is the length. Close that parentheses. Now we're going to subtract, so it's minus. We're going to subtract this area here because there's a window on that wall. Okay? All right. So that is for the master bedroom. Let's move on to bedroom 2. Bedroom 2, here we go. We actually have 2 exterior walls. Okay, and we need to remove this window area here. So it's 10 by 10. Let's just call it, sorry, 10 feet 10 inches. Let's just call it 11. And again 11. So we will say that for bedroom 2, we'll go equals. I'm over here, by the way, in this cell. Okay, so equals, open the parentheses. Now we'll say, so it's 11 feet long by 8 feet tall. There's 2 of those, so times 2. Actually, let's put it inside the parentheses just to keep it neater. Minus, we're going to subtract this window area. Again, it's on the north wall. There's 2 windows here. Okay. Next one, we have bedroom 3. Let's go to bedroom 3. So they call it bedroom 3 study. So again, here there is, there are 2 windows. So 9 feet would be 9 feet 10 inches. So that's basically 10 feet would be this width dimension, and the 12 is this length dimension. So we will do open parentheses 12 times 8 minus. All right, we need to remove the window area. Okay. Moving on to the great room. Great room is this is interesting. We'll have to consider this in 2 pieces. So there's the 20-foot long wall, and then there's the 16 feet 3 inch length dimension here. But this wall is not the full 16 feet. It looks to be about 2/3 of that. So 2/3 of 16. So 16 times 2 over 3 is, let's say, 10.7. Okay. All right. So we have here, where am I? Here we go. That's where I am. So we have equals. Oh gosh, I already forgot what the. Okay, 20 feet. Okay, so we have 20 feet times 8. Okay. Plus, we said it was. We said that it was 2/3 of that 16-foot wall. So 10.7 times 8. Now we need to deduct. Right, so that's the 2 walls. That's that east wall over here. That's the 20, and this is 10.7. Okay, so we're adding them. Now we need to subtract this window and this window. All right, because we have here these sliding glass doors. Sorry, not windows, but sliding glass doors. And then here, these are windows. We need to subtract those because they are already. Let me clarify. I'm subtracting them because they are already being accounted for, and when I populated this area where it's the area of the window or area of the sliding glass door. So it would be incorrect to say that the wall area would be, so for example, if let me get rid of these from the formula, 246 square feet is incorrect because really I need to be subtracting this and this, and so we end up with 138, a little bit less, meaning that the net wall area is going to be less. Okay, I hope that makes sense. I hope that's clear to everyone. And if not, please just drop a comment. All right, next on, we've got the mudroom. The mudroom is, well, they don't give us a dimension. Let's use our imagination. It's probably about 8 feet. Okay, let's go with 8 feet. Could be smaller, like 7 feet. Let's go with 8. So it's 8 times 8. That's it. Oh, it's got a door. I need to amend my formula, so I'm up here in the formula bar. So minus, and it's got this door here. All right, let's go head over here. So now I'm up to the master bath. Master bath, where are we? Master bath, we've got one exterior wall with a large window there. Again, so there's no dimension here, but so they're telling us that this dimension from here to here is 12 feet 4 inches. This is only a little bit shorter, so I'm gonna say this is like what, 10 feet, maybe 11 feet. So let's call it 11. All right, so we have 11 feet times 8 feet tall. Okay, now we need to, sorry, let me be consistent with what I was doing before with the parentheses. All right, now I need to remove from the master bath this window that's right here along this wall. All right, again, I'm right here. There's a window. I deduct the window square footage from the wall square footage. Okay, all right, now we are up to bath number 2. Okay, bath 2 is this room right here. Yeah, there's a closet here which belongs to bedroom 3. I did not include this little length of the wall in bedroom 3, so I'll do that now. I'll include it in bath 2, and that's fine. It's on the same side of the house, doesn't matter. Let's say it's probably, I don't know, 8-9 feet, let's say. That looks okay to me. So we say that it's open parentheses 9 times 8, and that's it. There's no window there that I need to take into account. Dining area. All right, again, I'm here. Let's go to the dining area. All right, here we are. So in the dining area, they tell us that it's 13 and a little bit by 11. So that means that this wall here is the 13, this is the 11. And I need to subtract these windows here. So I have equals, open parentheses, 13. 4 would be a third. Yeah, so 4 inches, because it's 13 feet 4 inches. 4 inches is a third of 1 foot. So it'd be 13.33 times 8 plus 11 times 8, right, because it's 13 by 11, okay, minus this window area. All right, we are almost done. We've got just the kitchen and the foyer. Let's look at the kitchen. Here we go. So they tell us that it is 10 by 12. So this is the 10 dimension right here. And there's a window there. So again, so it's open parentheses 10 by 8. Oops, that's a minus 10 by 8. Subtract this window. And there we go. We've got 62 square feet. And finally, we've got the foyer. So let's look at the foyer. The foyer has a door. This is probably a 6 foot wide over here. Actually, well, let's include this whole thing. Let's say that's about 8 feet, and then this is probably about, I don't know, 5 feet. Okay, so we're going to do 8 feet long times 8 feet high plus 5 times 8 minus this door. There we go. All right. Let's make sure that we have all of our walls. We've got the master, we've got the bedroom 2, bedroom 3, great room, mudroom, master bath, bath 2, dining room, kitchen, foyer. All right, that looks good. We could, okay, so notice that for the walls, we did not include this hallway area because those are not exterior walls, those are interior walls. We will include the square footage of this area here when we do the flooring and the ceiling. Okay. All right, so here's the floor plan, right? Now, you might remember this is what the home looked like from the outside. It's got this kind of attic. So I can see here, this isn't a second story, it's just a single story. It's got a vaulted ceiling. We need to keep that in mind. Actually, I think it does. Yeah, here we go. They've got a note about that here saying cathedral ceiling. Okay. That means on the inside it goes up to a peak. Um, But they've got these, you know, sort of shutters here, which, well, they're either there just for, you know, appearances to make it kind of look nice, or, well, really it should be some kind of like attic space, and so that's why you would have, well, all right, let's assume it's not the kind of attic. It is not the kind of attic that you can climb into. So what I'm talking about is, let's go here, let's go to ceiling. So we look at the ceiling types. Ceiling under attic. Or we could do a sloped roof ceiling. So a ceiling under attic would be something like this, where theoretically, you know, so there's some empty space here between this top of the ceiling and the, you know, on the roof. But the fact that they call it they say here that there's a vaulted cathedral ceiling. I'm going to go with this one, this sloped roof, okay? Look at the images, and it's some kind of shingles. We'll go with asphalt shingles. It's dark. The structure is a wood frame. The deck insulation, that's this top board here. Let's just assume that it's nothing, okay? You could do that. You could say R2. Let's just be a little conservative and say there's no deck insulation. Ceiling finish is at least a 1/2 inch gypsum, okay? Now ceiling insulation, I need to check the code for Arizona. I believe it's R38. Let me check that real quickly. Okay, so according to this Google search and according to this AI overview, they're saying it's R30. Don't know that I trust that. Let's see. It gives me this link. I'll click on that. It says King insulation. They're saying, okay, R38. I don't know where they got R30 from. R38 makes a lot more sense. Zone 4. Understanding Arizona's climate zone. Zone 2 is Southwest Arizona, including areas like Yuma. Climate Zone 4, Central Arizona, covering the Phoenix metro area. I don't know why they're saying Climate Zone 2 for Phoenix. That is a contradiction. They're saying here that Phoenix is a Climate Zone 4. Let me see if I can find something a little bit better than that. Here we go. Arizona Building Energy Code. Okay, right here. Phoenix. We have for a ceiling. So here we go. A wood frame, R13. We did that. Okay. And ceiling is R38. Let's go over here. R38. Where are we? Okay. So let's look at this U value. Okay, this is the overall heat transfer coefficient. We want this number to be as low as possible. So they're saying here the highest it could be is 0.3. And sure enough, that's what we get here. Now if we had less, so let's understand this U value number here. U stands for overall heat transfer coefficient. That's what it means. So let's see what happens if I were to use less insulation. This number would go higher. All right, you see that? So R7 would be, let's say, a thinner insulation, okay, or a not as good insulation, and the U value went up because I don't know if I talked about this. So as the insulation gets thicker or better, okay, the amount of heat that gets transferred is less. So the overall heat transfer coefficient will get smaller as the R value number gets higher. All right. So we've got our 029 number. Let's put that here in ceilings. We're going to call this a typical ceiling R30. We said our U value was 029. Okay. And CLTD means cooling load temperature difference. Again, we're going to grab that from here. So right here, 27. Okay. Actually, it might be a higher number. Let me check something real quick. Yeah, it's 33. It's not 27. It's 33. Meaning the actually that's a number you would retrieve directly from Manual J. Right now, this cooling load number is not correct because it's defaulting to the default location right now for the software. But I'm going to grab it from here, which is the 33. And so what in the world is this? Well, it's the CLTD stands for cooling load temperature difference. Basically, it's the temperature that's outside up on the roof compared to the temperature right inside the home. Okay. So now that we've got our ceiling value, let's go back here. Okay. So we're on the J1 form tab. We'll go to this section. We don't have any below grade walls or partition walls, not for this particular example. A partition wall, by the way, would be like, for example, separating, let's say there was a garage here, and typically a garage is uninsulated. Whereas here, above grade walls, this is referring to exterior walls. For the ceiling, there we are. We created this ceiling here. So now, in these cells, we need to enter the net area of the ceiling. So that's going to basically be the same as the number that you see here, this 16 by 3, okay? This 16 feet, 3 inches by 20 feet, okay? Here we go, master bedroom. So let's start at the master bedroom right here. Now I think the cathedral ceiling is only here in this area. And I'll explain why in a little bit, why that's relevant. So here we go, master bedroom. We've got 12.33 times 16. So equals 12.33 times 16. Now we would not deduct any of these values because the windows don't deduct from the ceiling area. However, if we had skylights, okay, then I would deduct because a skylight breaks up the ceiling area, right? So I would deduct the skylight. Okay, so we just did the master. Let's go to bedroom 2. Where are we? Bedroom 2, we've got basically 11 by 11. So equals 11 times 11. All right, bedroom 3. So bedroom 3 is 10 by 12. So 10 by 12. Then we have the great room. So 16 and a third, basically pretty much by 20. Now I need to take into account this cathedral ceiling. So what is that and why does that matter? Well, so here's what I'm going to do. I'm going to open a PowerPoint just so that I could draw. All right, so now it's a little tricky because they don't actually give us the height. But so let's say this is our house, okay? And the house has this kind of roof, a roof that's got a peak. Okay, so right now in this image, we're looking down. We've been considering the master bedroom as just a rectangle for the ceiling. But if you consider the fact that, and let's put a line right down that middle, and let's make it black. There we go. All right. So now, if we consider the area of, I need to, hold on. This will all make sense in just a minute. I need to shift everything down. Okay. Okay, so now, I need to consider the total net area of this ceiling that's on a slope. So if I have this dimension here, okay, and if I'm given, well, actually, okay, so let's call this is, you know, like a, remember from school, okay, if you have a triangle, we're going to use some Pythagorean theorem here, okay. Okay, so we will call this, no, not there, what's going on? This is the base of the triangle. Okay, this is that's A. Okay, and this here is the hypotenuse of the triangle. You guys remember that, right? So this dimension right here, okay? Let me move this up so it looks a little bit more like it belongs to, there we go. All right, so I'm trying to find H. So I know B, dimension B is right here, it's 16 feet 3 inches, which I'm just gonna call it 16.3, it's close enough. Now I don't know the height. Let's assume for a minute that this height A is 4 feet. Why not? It's a pretty reasonable number. So I'll say this is 4. And then this here, we said this is 16.3. So we need to find H. So what this is, if you guys remember Pythagorean theorem, so H equals, why is my caps, okay, it's the square root, oh actually I could do it like this, hold on, I forgot that I'm in PowerPoint right now, let's get a little fancy. H equals square root of 4 squared plus 16.3 squared. All right, and so what's that number? Well, let's see, it's right here. Let's do 4 times 4 is 16 plus 16.3 times 16.3. So that total, right, is 282, let's call it. Okay, so 282, whoa, 282 to the 1/2. Raising something to the power of 1/2 is the same thing as the square root. Okay, equals, all right, so 16.8. Okay, equals 16.8. So that's what we're going to do here. We're going to say now that the area of the ceiling is 16.8 times 20. And this is for the great room. Where are we? So here we go. So right here, this cell equals 16.8 times 20. There we go. All right. Now what about the mudroom? Is the mudroom included in that vaulted ceiling? No, it's not. What did we say the mudroom was before? I don't remember. Well, here, it's 9, so 10 feet this way. And I think I said, what, 8 feet? So it's 10 by 8. So equals 10 by 8. Now let's go over to the master bath. Where are we? Master bath, that's this whole area. Oh, I didn't include last time well, I did include this. Oh, I did. I did not include this portion of the wall. Okay, so first of all, let me add a little 4 feet to the wall for the master bath. Yeah, because that's a little strange. There's this big walk-in closet, which is technically in the master bath. It's a little bit strange. I've never seen that before, but anyway. This is at least 4 feet. So I need to add that. So instead of 11, it's really 11 plus 4, which would be 15. Okay. So now I just had 15 is this dimension here. Yeah, that looks about right. So 15 by 12.4. Excuse me, by 12 feet 4 inches, which is a third. So that would be 12.33. So here we go. We go 15 times 12.33. Okay. Now we are up to this room here, bath 2. All right, you see that? Bath 2. Okay. Bath 2, where are we? Is this 9, so 10 feet wide, that's this dimension here, and I think I said this was 8 feet, so 10 by 8 equals 10 by 8. Now let's go to the dining area. The dining area, here we go, another cathedral ceiling. They're showing you where it is, by the way, right there, this sort of beam looking thing. So it's 13 by 11. 13 is this way, 11 is this way. So 11 stays. I need to figure out, let's go back to this triangle. So now this is, and it's 13 feet 4 inches, so that's the 13 and a third. So 13.33. And so now this number changes to 13.33. And so this number is going to be very different. So let's go back to the calculator. So we have 4 times 4 plus 13.33 times 13.33 equals 194, let's call it. Okay, so we're going to say 194 to the raised to the 1/2. Hold on. I hit that. Here, so 1393. I hit the enter button twice. So 13.9. Okay, that makes sense. Let's go 13.9. So when we're doing this dining area, we're going to say that it's 13.9 times 11. So equals 13.9 times 11. For the kitchen, okay, we're almost done. For the kitchen, it's 10 by 12. It is not a vaulted ceiling, so 10 by 12 equals 10 by 12. Foyer, the foyer is kind of vaulted, not really. Let's look at that image that they provided. No, it's not. Well, it's kind of vaulted. And interesting, it's funny, they don't actually show it. No, they show this. All right, so let's just, so the kitchen should be a little bit, instead of 10 by 12, we'll call it, I don't know, we'll call it 12 by 12, okay? And the foyer, it's quite small. What did we say before? We said it was like 8 by 5 or something. Well, so we'll call it, we'll say it's 8 by 8. Right, 8 by 8, that's good. Now we do need to include the hallway. So I did not do that yet, so here, hallway. And it only will be taken into account for the ceiling and for the floor. So it's long, it's this, we said this was 8 feet, this is 12, so 8 plus 12 becomes 20. We said this was also, I think, 8 feet, so that's 28, plus 10 is, well, really it ends here because I'm saying that this 10 by 12 is the kitchen. So it's, where are we? 8 plus 12 is 20, plus another 8 is 28. Okay, so it's 28 by, it's typically a 4-foot wide hallway. So equals 28 by 4. All right, that's the ceiling area for the hallway. Okay, now let's get to the passive floors. Passive floors meaning like it's possible you could have like heated floors. Okay, the manual J8 does, Speedsheet does not work with that kind of flooring. So let's head over to our trusty tool, the WriteSoft, and let's get to work on flooring. In Phoenix, even though obviously this picture does not look like Phoenix, but in Phoenix it's very common to have a slab on grade, meaning that the concrete foundation is not buried underground. I mean, obviously it's a little bit buried underground, but it's just a chunk of concrete sitting on the ground. as opposed to in many places you might, first of all, you might have a basement, if it's on the East Coast or other places, or you might have some kind of crawl space. Let's just show everyone what all these things look like. Let's head over here. Let's look at a crawl space. Let's look at some pictures. Here we go. These are crawl spaces, and they're called a crawl space. They are called crawl spaces because there is, barely room to crawl, and this is under the home, meaning there's no basement underneath here. Let's look at slab on grade. Let's see what that looks like. All right, so slab on grade. There you go. It's literally just a chunk of concrete poured onto, the soil, basically. What other options are there? We could have a basement. Obviously, we know what that looks like. All right, so now let's just go with what's really typical here in Phoenix on grade. So the soil is usually light dry. It's very dry soil. Okay. It's on grade, meaning it's sitting on the top layer. Okay. No edge insulation. Let's see what that looks like. Or some kind of insulation protecting the outer perimeter from any heat transfer. We'll just say none. Is there any slab insulation? Right. So you might have just a little bit. We're going to assume that there's none. Actually, you know what? Let's go back. They talk about here. This is for, here we go, slab. Okay. NA. So meaning there's no requirement for a slab insulation in Phoenix. Actually, this is great. I'm glad I pulled this up. Okay. So no slab insulation. Let's say the flooring is hardwood. Yeah. So our U value is 0. So let's go to this tab here for flooring. We said our U value is, where are we? We have to find the right one. This is for floor over an enclosed crawl space. Nope, wrong one. Floor over an open crawl space. Nope. Partition floor, that would be like, for example, if we had already done the basement and there's the first floor is the ceiling of the basement, right? So that would be a partition floor, but that's not what we're working on. We're not talking about a basement floor. We are talking about concrete slab on grade. So we need here this number here. So that's 0. Let's see, what do they have here for here, a slab floor. That's interesting. In this code, they're giving a manual J8 U value of 0. But manual J Speedsheet is looking for an F value. The one they give as an example is 0.48. But that uses R10. Okay. The U value is going to be, okay, this UNOM, this nominal U value is going to be similar to the F value. Now again, the higher this number, the more heat will transfer through. Okay. So I will use this higher number here, this 0.575, to be conservative, meaning that I'm going to assume that a decent amount of heat actually does leak through. We'll call this typical Phoenix slab on grade. All right, let's go back to our J1 form. And passive floors, where are we? Slab. Sorry, okay, here we go. So passive floor, so slab, perimeter feet. Now, we're not doing, notice here, it says right here, perimeter feet. You see that? We are not doing the area of the floor. We are doing literally just the perimeter of the exterior. So for example, here, the great room, the floor area is 16 by 20. We are just interested in this 20 plus this, I think we said this was like a 10.7 or something, right? So let's get to it. So we got the master bedroom first. Let's start there. So the master bedroom is 16 feet. So here we go, right here, 16. Then if we go to, wait, what's the next room? Bedroom 2. So bedroom 2 is, where are we here? So that's 10, so 11 plus 11. Why does it keep doing that? All right, equals 11 plus 11, which is 22. Okay, now we have bedroom 3. Bedroom 3 is basically 10 feet. So we have 10. Now for the great room, we have 20 plus 10.7. So it equals 20 plus 10.7. Then for the mudroom, we said this was 8 feet in this direction. So that's 8, oops, whoa, what am I doing? 8 feet. Now we have, I'm over here. Nope, I'm over here. Okay, so the master bath is quite big because of this. This is at least 4 feet, and this looks to be about 10 feet or so. So 14 feet, I think we said in the other one 15. Let's go with 15 feet. Bath 2 right here. This is including closets, about 8 feet. Let's go with 8 feet. I just need to move the spreadsheet over, so I'm over here. So the dining area has 13 1/3 plus 11. So equals 13.33 plus 11. The kitchen is just 10.2. So equals, well, 2 over 12. 2 inches out of 12 inches would be 1/6. This is like 10.18 or something. Right, because equals, so 2 over 12 is, well, anyway, so let's just call it 10.2, right? Okay, now for the foyer has 2 exterior right here, so this exterior and this exterior. So we said this was 8 by 5, so equals 8 plus 5. Notice I'm not doing multiplication, right? I'm doing addition. There shouldn't be any multiplication here. It should be all just addition. There we go. Yep, it's all just addition. Okay, because we're not looking for area, we're looking for, and the hallway obviously has no exterior portion to it, so we do not include that in the floor. Because hold on, let me clarify. That's because we are talking about a slab on grade. If this was like a basement type of, if this house had a different kind of flooring where like it had a crawl space or something like that, then yes, I would be doing the total square feet, the area. Why? Because let's go back to the image of the crawl space to understand that a little bit more. Let's go to crawl space, because you have here air. This air is, well, actually not in this particular image. This looks like it might be somewhat enclosed. Let's look at this one. This is just a raw crawl space. Okay, you can see ugly dirt under there, and this one too. You can see there's like what do they call it? It's like it's basically a hole in the wall that they cover up, right? It's for ventilation. Okay, so all of the regular air from the outside, whether it's cold air or hot air, whatever it is, all of this air is the same temperature as the air outside. So you can see here, this is the underside of the first floor. So there's going to be heat transfer all the way this entire area, wherever the floor is, not just along the perimeter. Okay. So that's what I would use here. I would do, let's say, whatever that number was. I think it's like 28 times 4 for area. Here, they're just looking for the perimeter in the situation where it's a slab on grade. Okay, so that finishes up the floors. Next, we need to move on to this infiltration area. So this is a little bit interesting. You got to read the manual J for this. Okay, basically you got to start, looking into things like, so infiltration means basically any leaks or gaps or anything like that. So for now, we'll just go with average. I'm looking at the clock here. I see this has been a 45-minute video. Let me just finish up a couple things real quick. So what's the total square footage of the home? I believe here it says that did I? Well, it's 63 feet by, let's say this is like, take off, what, 5 feet, so 31. So it's going to be 63 by 31. Whoa. Equals, I think I did 2,000, or was it 1,800 square feet, maybe was what I said when I created this. I don't remember this anymore. Oh, here we go. So 1628 is the total square foot. So we're going to enter that right here is the heated and cooled area. So 1628. What's the above grade cubic feet? So in this instance, it's going to be whatever the square footage is times 8 because the walls are 8 feet tall. Now, how many occupants are there? So in the master bedroom, you have 2. And in bedroom 2, you've got 1 occupant. What is going on? There we go. Okay. Now, appliances. There's going to be like a computer, a TV, etc. Well, let's say that all of it is, well, let's divide it up. Let's say there's a large TV in the master bedroom, and then there's some other thing in the great room. All right. So I will do a follow-up video for some of these other detailed bits here. They do matter. They certainly do matter. But let's just, for a second, pretend that we're done here. And the reason why I say that is let's go over to the Summary tab. And so here we are, voila. We see that now it calculates for each bedroom individually the heat loss, okay, and the heat gain, meaning this is the heat, this is the energy leaving the home in the wintertime. This is the energy entering the home in the summertime. Again, notice I did this for Phoenix. Phoenix is really quite hot over here in the summertime. So in Phoenix, we have a larger cooling load compared to our heating load. All right. And then these are the totals that we're going to look at. So total sensible heat loss. This home is losing 18,527 BTUs per hour in the wintertime, like the entire home, okay? And heat gain, total cooling load, that's the combination of sensible plus latent. Basically, latent means things related to humidity. Sensible means dry heat. Latent means heat that's captured in humidity. Again, Phoenix is super dry, so we're always going to have a very low latent load. So the total cooling load is 26,713. So some of you may be familiar with air conditioning tonnage. So you can divide this number by 12,000. So why am I saying 12,000? Okay, let me explain. So we will say BTU per hour to tons. Oops. Okay, so you divide 1 refrigeration ton is equal to 12,000 BTUs per hour. So you take this number, this 26,713, so 26713 divided by 12,000, and approximately the home will need a 2.2 ton cooling unit. Now the way to do this properly would be to follow it up with a manual S, which is the proper method of selecting equipment, because it's not just about matching the tonnage, you actually got to match the specific machine to see if it's up for the job. Maybe I will do a manual S video, and maybe I'll get into some more of these details that I really glossed over quickly. Again, these come straight out of the manual J. You really got to be familiar with it, but just real quick, I'll say this basically is what kind of ducting is it and where is it? Is it in the attic? Is it in a crawl space? Is the crawl space open to the environment like that picture I showed before, or is it somewhat enclosed? all of these things, these details, they do matter. The R value on, meaning the insulation value on the ducting, of course, that matters. Perhaps I'll do that either in a part 3 of this video, or in a follow-up video. Leave me some comments. Let me know what you think about that. But this is what we look for when we're done. We look for the total sensible, and we look for this is for the heating, meaning this is how much energy we need to heat the home in the wintertime, and this is what we need to cool the home in the summertime. Alrighty, thank you very much.